Good day, everyone. Our topic for today is law of indices, and I shall be giving you the laws. Let's start with multiplication law. This multiplication law is divided into multiplication law with the same basis and multiplication law with the same powers. Take a look. 2 raised to power 3 multiplied with 2 raised to power 4. You could see the bases here are the same. Because the bases are the same and we are multiplying, these have to do with multiplication law with the same basis. And the law states that we pick one out of the basis, the multiplication sign in effect becomes addition of the powers. We then have the powers adding, and that gives 2 raised to power 7. However, these can be compared with multiplication law, but this time around with the same powers, but different bases. Take a look. 3 raised to power 2 multiplied with 4 raised to power 2 equal to. This is a situation whereby the powers are the same, but the bases are different. And the law states that we should pick one out of the same powers that are the same and multiply the bases, which means in effect, the multiplication remains multiplication. So we have 2, which is the power, and then the basis 3 times 4. And this gives 12 raised to power 2. In conclusion, multiplication law is divided into two, one with the same basis and one with the same powers. For the one with the same basis, we pick one out of the basis and we add the powers. But for one with the same powers, we pick one out of the powers, still we multiply the basis. And similar thing is applicable to division law. So we take a question on that. 2 raised to power 8 divided by 2 raised to power 6 equal to. Here is division law with the same basis. So we pick one out of the basis. Instead of division, in effect, we subtract the powers. So we then have 2 raised to power 8 minus 6, and that is equal to 2 raised to power 2. In similar manner, we have division law with the same powers, but different bases. Take a look at this. 8 raised to power 2 divided by 4 raised to power 2 equal to. Here the powers are the same, but the bases are different. We pick one out of the powers that are the same. And for the basis, we apply the division the way it is. It therefore becomes a divided by 4, and that is 2. This then becomes 2 raised to power 2. Apart from this multiplication law and division law, we have the other laws, which include zero power law. And the law states that anything at all that is raised to power 0, irrespective of what it is, that automatically the answer becomes 1. Therefore, 4 raised to power 0 is 1. In similar way, s raised to power 0 is also equal to 1. Then, we wipe off. We also have power and bracket law. This obtains in a situation whereby we have a number or a base inside a bracket with power, yet another power outside the bracket. Take a look. 2 raised to power 4 inside the bracket, and outside the bracket 1 all over 2 as power. This is power and bracket law. The law states that we retain the base inside the brackets, and the power inside the bracket will be used to multiply the power outside the bracket, because bracket stands for what? Multiplication. So we have 4 times 1 all over 2, and this gives 2 raised to power 2 goes here 1 and 2 goes here 2, power 2, and this is the answer. Then apart from this, there is also negative power law. Take a look. 4 raised to power minus 2. This law states that in a situation whereby we have a power with negative sign, that negative turns the base to inverse. But I would rather go this way. When you have a base with negative power, ignore the negative sign first. Ignore the negative sign, and then we have left 4 raised to power 2. And 4 raised to power 2 is the same as 4 times 4. Put it in brackets. And the negative sign that was part of the power can then be brought in. Now as power, we have minus here. And 4 times 4 is 16. And it then becomes 16 raised to power minus. What then is the effect of this minus, which can also be written as minus 1? The law states that this minus 1 will turn this 16 upside down. It then becomes 1 all over 16 instead. However, this very question, 4 raised to power minus 2, can still be solved by not ignoring the minus ab initio, but using the minus to solve. If we were to use this minus, the minus automatically becomes 1 all over. Yet, without the minus, we have left 4 raised to power 2, which comes under here as the denominator of this fraction. And then it goes to become 1 all over 4 raised to power 2, which is 4 times 4. And that is 1 all over 16. Then another law is fractional power law. And by fractional power law, it means that this time the power is a fraction. Take a look at this. 8 raised to power 4 over 3. The 4 over 3 is the power, and this power is a fraction made up of 4 as numerator and 3 as denominator. The best way to solve this is to express the 8 as a product of prime factors. How? We bring out that 8 and find what can divide it. The smallest thing that can divide 8 is 2, which is the first prime factor. And 2 goes in 8 is 4. 2 can still go to give 2. 2 goes again to give 1. Then, this 8 has been expressed as 2 times 2 times 2. And it then means that another way of writing 8 is 2 times 2 times 2, which is the same thing as 8. And the initial power of the 8 is 4 all over 3. 2 times 2 times 2 is the same thing as 2 raised to power 3. We rewrite it as 2 raised to power 3. And this power We then multiply this power that is outside. At this point, 3 can cancel 3. We have left 2 raised to power 4. And 2 raised to power 4 can still be written as 2 times 2 times 2 times 2. And that is 16. However, there is still another law that combines the negative power law and the fractional power law together. And it is called negative fractional power law. Take a look at this question. 27 raised to power minus 2 over 3. This involves 1. Negative power, 2. Fractional power. So the knowledge on both can be adopted to solve this very question. Maybe let's apply the negative power first. This negative sign goes to effect this 27, turning it upside down. It then becomes 1 whole over 27. Then we include this in a bracket, and outside the bracket we retain this power, which is 2 over 3. And by this 2 over 3 being written as power outside the bracket, it means it is both for the numerator and for the denominator. Then it means we can use the 2 over 3 for 1 and 2 over 3 for 27. And 1 raised to power 2 over 3 is the same thing as 1, because anything raised to power, 1 raised to power anything is the same thing as 1. And this 27 will also be raised to power 2 over 3. That is 27 raised to power 2 over 3. And then 1 whole over comes. For this denominator part, we apply fractional power law, which means we express 27, that is the base, as a product of prime factor, and 27 written. The smallest prime factor that goes is 3. Here is 9. 3 again goes. Here is 3. 3 again goes. Here is 1. Then 3 has gone how many times? 3 times. And that can be written as 3 raised to power 3. Remember, this power 2 all over 3 will still come here to multiply this new power, which is 3. And this 3 cancels 3. Our leftover here is 3 raised to power 2. And that is 1 all over 3 raised to power 2, which gives us 1 all over 9. Then, at this juncture, having explored and exploited all the laws of indices, it is right for us to take questions that border on them. So we quickly look at questions on law of indices. Question 1. We have 625 raised to power minus 1 all over 2, and then times, open bracket, 1024 raised to power 1 whole over 5. Solve. To solve this very question, let's start with the negative power here. The negative sign turns this 625 upside down. It therefore becomes 1 whole over 625. We can then bring down this 1 over 2 that was the initial power as the new power here, and that is 1 over 2 multiplied with, you see this 1024, we break it down as a product of prime factor. It then becomes 1024. Smallest prime factor that goes is 2. Here is 5. Here is 1. And here is 2. 2 again. Here is 2. Here is 5. And here is 6. 2 again. Here is 1. Here is 2. And here is 8. 2 again. Here is 6 and here is 4. 2 again, 32. 2 again, 16. 2 again, 8. 2 again, 4. 2 again, 2. 2 again, 1. Let's count how many 2's we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 2 into 10 places to be written as 2 raised to power 10. Mind you, this new power that is 10, we multiply the power outside before. That is times 1 all over 5. And the same way we break down this 625 again. 6 to 5. 5 can go. 5 goes. And that is 1. In 12, 2. In 25, 5. 5 goes. 2. In 25, 5. 5 goes. 5. 5 goes. 1. So we then write 1 all over. The 625 will then be written as 5 raised to power 4. We use the 4 to multiply the old power, which is 1 all over 2. And everything here multiplied with 2 raised to power. 5 cancels itself to cancel 10, and that is 2. 2 times 1 is 2. That is 2 raised to power 2. 2 can go here and go here. That is 2. 2 times 1 is 2. And that is 1 all over 5 raised to power 2. Everything times 2 raised to power 2 is 4. Then 1 all over 5 raised to power 2 is 25. Multiplied by 4. And this 4 is the same thing as 4 over 1. And our final answer here is 4 all over 25. Then we go to the next question. Let's look at 9 raised to power 3 over 2. Everything multiplied with 9. To solve this question, we discover that this has power, but this very one does not have power. And the law states that any number at all that doesn't have power, that the power is 1. So we give 1 as power to this. And then we proceed. So to solve this one separately, we break 9 as smallest number that goes is 3. 3 here, 3. 3 here, 1. And that is 3 raised to power 2. We multiply this power 2 with the old power. That is times 3 over 2. And then everything multiplied with. What we have here is 9 raised to power 1, which is still the same thing as 9. And then 2 cancels 2. We have left 3 raised to power 3, which is 3 times 3 times 3. And that is 27. Times this 9 we have here. And 27 times 9. That is 243. We take another question. Square root of x raised to power 2 over 3 times y raised to power 1 over 2. Everything times x raised to power minus 2 over 3 times y that is raised to power 3 over 2. Everything times third roots of x raised to power 3 over 4 times y raised to power minus 1 over 2. Then, to solve this question, what we do is we use the square roots that covers these two things as power. And the square root coming as power will come as 1 all over 2. The same thing here. We use this third root that covers these two things here as power. And the third root coming as power will come as 1 all over 3. We then have x raised to power 2 over 3 times y raised to power 1 all over 2, everything raised to power 1 all over 2, which stands for the square root that covers them, times s raised to power minus 2 over 3, times y raised to power 3 over 2, times we have s raised to power 3 over 4, times y raised to power minus 1 all over 2, covered, and this third root becomes power 1 all over 3. At this point, we apply power and bracket law. The power outside the bracket multiplies each of the power inside the bracket. So we use this 1 over 2 to times these powers. We use this 1 over 3 to times these powers. It then becomes x. 1 times 2 is 2. 2 times 3 is 6. Times y. 1 times 1 is 1. 2 times 2 is 4. Times x raised to power minus 2 over 3. Times y raised to power 3 over 2. Times. We use this power outside to times each of the powers inside. We then have x raised to power 1 times 1 is 3. 3 times 4 is 12. Times y. 1 times minus 1 is minus 1. 2 times 3 is 6. At this point, we collect the like terms. And the like terms here have to do with the ones with the same basis. We pick x, x, x separately. Times we pick y, y, y separately. So when we pick s, 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 we have s raised to power 2 over 6 times this x raised to power minus 2 over 3 times this x raised to power 3 over 12. We are done with x. We go with y. Y raised to power 1 over 4 times y raised to power 3 over 2 times y raised to power minus 1 over 6. Then, what does the law of multiplication with the same base say? It states that whenever we are multiplying and they are the same basis, we pick one out of the bases and we add the powers. So out of this x, we pick 1. And then we have the power here, which is 2 all over 6. Plus minus is minus. 2 all over 3. Plus 3 all over 12. Then multiplied with the y itself, of which we pick 1, which is this one. And then we add the powers together. Then we have 1 all over 4 plus 3 all over 2. Plus minus is minus 1 all over 6. At this point, we solve this part first, and that is x. We go like this, and that is 12. We bring down this minus, which is this. We go like this, and that is 6. All over, we go like this, and that is 18. Everything plus 3 all over 12. Then everything times y. We take this part first. Then we go like this, and that is 12. Plus, we go like this, and that is 2. All over, we go like this, and that is 8. And then we join this minus 1 all over 6 to everything. At this point, 6 minus 12, that is x raised to power minus 6 over 18 plus 3 all over 12, everything times y. 2 plus 12, and that is 14 all over 8 minus 1 all over 6. At this point, 6 can go here to give us 1. And when it goes here, that is 3. 3 can go here to give us 1. And when it goes here, that is 4. Then 2 can go here to give us 7. And when it goes here, that is 4. So we take everything the way they are left. We have x raised to power minus 1 all over 3 plus 1 all over 4. Everything times we have y raised to power 7 all over 4 minus 1 all over 6. At this point, let's wipe off everything we have here and continue from where we stopped. So we take this way, but before then, we bring down the base. We go this way, and that is 3. And then we bring down the plus. We go this way, and that is minus 4. Everything all over. We go this way, and that is 12. Then times y. We go this way, and that is 4 minus. We go this way, and that is 42 all over. We go this way, and that is 24. At this point, minus 4 plus 3 is minus 1. We thereby have x raised to power minus 1 all over 12 multiplied with y. If we pick 1 here and add to 2, it becomes 12. 12 minus 4, and that is 8. And here is left 38 all over 24. Then 2 can go here to give us 19. 2 can go here to give us 12. We then have, because of this minus sign, it turns this x upside down. We then have 1 all over the x itself that is still raised to power. This 1 all over 12 without the minus. Everything multiplied with the y now raised to power 19 all over 12. At this point, under this y, there is 1. The numerator times the 1, and that is y raised to power 19 over 12 all over. The denominator times this 1, and that is x raised to power 1 all over 12. Then, this is our final answer. Then, we take this question. Three root 2. Everything raised to power 2 over 3 multiplied with, open brackets, 2 root 3. Everything raised to power 2 over 3. This is multiplication law. Let's consider the bases. They are not the same. Let's consider the powers. They are the same. What does the law say once the powers are the same and we are multiplying? It states that we should pick one out of the powers and multiply the bases. So let's go. Out of this power and power that are the same, we pick 2 all over 3. Still retain it as power. We then multiply these bases, which is 3 root 2 times 2 root 3. And this gives 3 times 2 is 6. Root 2 times root 3 is root 6. And everything will now be raised to power 2 over 3. But then, 6 root 6, how can we re-express this? How can we take this 6 inside the roots? To take this 6 inside, we must first square it before it can be permitted to come inside to join this other 6. We then have square root of, that is inside brackets. This 6 squared is 6 raised to power 2 times this 6 that is already inside, which is 6 raised to power 1. Everything raised to power 2 over 3. And 6 raised to power 2 times 6 raised to power 1 is the same thing as 6 raised to power 3 still. Then we have, open brackets, square root of 6 raised to power 3, close the bracket, raised to power 2 over 3. At this point, Let's effect this square root sign. Before we bring in this square root sign, let's write only the content of the square root, and that is 6 raised to power 3. And when the square root sign comes and wants to be in the position of power, it assumes 1 all over 2. Therefore, this 3 is the old power that the 6 had. And this 1 all over 2 is now the square root. And then there is bracket, which also stands for times. And the former power here outside the bracket is 2 all over 3. At this point, 2 cancels 2, 3 cancels 3. Left over is 1. Then this is 6 raised to power 1. And 6 raised to power 1 is the same thing as 6. Our final answer is 6. At this juncture, I want you to expect the next topic we are going to be treating. Having taken laws of indices, the related topic is logarithm. And the logarithm that should be our concern is that does not have to deal with table. See you in our next class. Thank you.